Okay, I'm gonna get started. My name is Micah Borghese. I'm the program director of the Midwest Block-a-Thon. I'm also the president of KU Blockchain Institute. We're kind of putting this together in conjunction with our blockchain club at the University of Kansas. And I wanted to make some announcements before this, just to say, if you're not receiving emails from us, if you haven't got any email from hack@kublockchain.com, please reach out to us at that email to make sure that we're getting that information into your mailing list. And also, this is going to be recorded and uploaded to YouTube so that you can rewatch any content on here, and also have you read through our Hacker Doc, which has a lot of information about like the bounties and stuff. I just want to say, for those of you joining, there's over 100 people that have applied so far. So you guys are going to be the first to know about, Pinata's prize track, which is $800. They're giving away $800 at the Midwest Block-a-Thon to one lucky team who uses their platform. So we're super excited about that. And also some future workshops where you can learn the details about what we're doing. So Hackathons 101 is essentially going to be two Kubi execs, myself and then Caleb, who will be talking about what it's like to compete at hackathons. Maybe you're a beginner, maybe you've never gotten to experience a Web3 specific hackathon. We're going to be talking a little bit about what these kind of hackathons look like, and especially some tips for considering the time constraint that you guys have. Some tips in following the judging criteria for this hackathon specifically. And then next Thursday, we're going to be doing a DApp workshop. We're going to be building an NFT gallery. So we're going to be from scratch. You're going to follow a tutorial with us, be able to ask any questions about um, what kind of like what smart contracts are again, if you need a refresher, how to code, how to put everything together just for that project. And obviously, these are both going to be in person and over Zoom. Free food if you do come in person to these are the classrooms next to it at the University of Kansas. And then that's all for my announcements. I do have a couple exec members available to answer the chat if you have any questions on your guys' part. But I'm going to hand it over to Steve Simkins, who's going to do a what are smart contracts workshop. He's head of developer relations at Pinata. He's been doing blockchain development since 2020. So he's kind of, been around since, the NFT craze and stuff like that. So super excited. I've never had a workshop, but I've never heard a workshop by Steve. So super excited to hear from you.
So thank you so much, Mike. I really appreciate it. Just want to make sure is my screen up? Can everybody see it? Are we good to go? There we go. Awesome. Sweet. Thank you so much. Yeah, so again, yeah, I'm really excited to share this kind of brief walkthrough of, what are smart contracts, and we're going to actually get into a lot of the code and see how everything works. So whether you are a straight up beginner or if you've done some smart contract stuff before, hopefully this is like a nice in between where if you're new, it might push you a little bit, and if not, then maybe you might learn something along the way here. So we can move to the next slide here. Yeah, so as Micah said, my name is Steve. I am the head of developer relations at Pinata. You can find me pretty much anywhere on the web with my handle, Steve Dillon Dev. And yeah, as head of developer relations, my job is just to make sure that all the developers that use Pinata are happy and that the experience for them is, the best we can provide. And that usually involves writing documentation, manage all of our open source software, such as our SDK, CLIs, things like that. Write lots of content, whether it's blog posts, tutorials, videos as well. So if you go to our YouTube, I have some video tutorials up there. And of course, I do a lot of support. So if anybody has questions, whether it's on our app itself or Discord or any other kind of social platform, I try to answer those and just make sure everyone's taken care of. And I have a very large passion for building developer tools. I love building tools that help developers succeed. And so that can take the form of really anything, whether it's like a web app or CLIs, SDKs. I absolutely love it. And I love the satisfaction of another developer finding satisfaction in using that tool. So that is my big passion project. And I've loved doing it for blockchain and anything using cryptography. It's just my bread and butter. Apart from that, hobbies and stuff, I'm pretty big nerd for keyboards and terminals. So you have any like Vim or NeoVim nerds out there? I love that kind of stuff. Um, and apart from that, apart from tech, I really love photography, coffee, books, just all of your normal hipster stuff. So getting into the topic, what are smart contracts? If you're familiar with blockchains, maybe a simpler one like Bitcoin. With Bitcoin, it's just a single ledger that is recording transactions between multiple people. So, Alice sends Bob some Bitcoin. That is a transaction on the Bitcoin blockchain and it is recorded. And it's a immutable ledger. You can't go back and change it. When it comes to Bitcoin, that's kind of where it stops. There's not really much else you can do. People have found ways to get around it, but it's not as open and as extensible as other blockchains. And that a lot of that changed when Ethereum came out and came up with something called the EVM. And the basic concept behind it was what if we wrote these programs or smart contracts that could live on the blockchain and could run on the blockchain and basically record transactions like an immutable ledger and have like this history and this factor of immutability and in a lot of sense trustlessness, this idea that you don't have to trust somebody else, the code is going to execute no matter what, no one can control it, these kinds of principles. And that's exactly what smart contracts are. They're just pieces of code that can run on a blockchain. And the way it does that is they're generally written in a language like Solidity, and there's going to be a compiler that will compile the Solidity program that you write into bytecode. And that bytecode will live on the blockchain and it'll be run on the Ethereum virtual machine. And while it lives on the blockchain, you can basically interact with that contract. Other contracts can interact with each other. If you have an account, like a smart contract wallet or just a regular blockchain wallet that if you want to interact with these smart contracts, that's usually how it works. So whether it is NFTs, tokens, DAO voting, all these different applications that can run decentralized, that's basically how it's working. And I think a lot of the time it's easier to show you how stuff is built versus just talking about it and looking at some pictures and stuff like that. So we're actually going to jump into a quick demo and we're going to build actually a couple of smart contracts. So we're going to start in this right here. So some of you might be familiar with Remix, some of you may not be. Just remix.ethereum.org. And Remix is kind of like a smart contract playground. Makes it very easy for you to write smart contracts, test them, and even deploy them to actual blockchains. So it can do quite a bit, and it's a really nice place just to explore. You don't have to like necessarily have a wallet or have testnet ETH or any of this stuff. It's a great place to start. And the smart contract we're going to write today is basically like a Facebook wall. I'm a bit older, so this might be different for y'all, but back in the day, you had Facebook and you could write on somebody's wall and it would just have a line of posts. And that has like a lot of great functionality and great display of what smart contracts can do. So that's what we're going to do. I'm going to go ahead and click create new file. I'm just going to call it fbwall.sol. All right, and so we basically have this empty file. The first thing we're going to do is declare a license. So we're going to do sbdx license, and it's identifier, and that's going to be MIT. So that's just one of the things Solidity kind of requires for first getting started. The next thing is going to also generally require is like the Solidity version that you're using. So the compilers can match up and all your features match up. So we're going to just do pragma. Oh, little extra there. Pragma, Solidity, and let's do, I think it's going to be 0.8.20. That should be sufficient. And then we're going to go ahead and declare our contract. That's going to be contract, call it FB wall. And there we go. That is the beginning of our contract. There's not much there yet, but we're going to fill that in. And the first thing we're going to do is going to declare some state that will adjust and change over time. So that is going to be the total number of posts on our Facebook wall. So we can very easily say we have a total of 12 posts or something like that. So we're going to use a unsigned integer with 256 bits, and we're just going to call it total posts. All right. And the next thing we're going to add is something called a smart contract event. generally when you're coding, you might have something like a console log because you're trying to print out something and debug or something like that. Smart contracts have something similar called events, where you can basically pass information in when a function is run, and it prints out and records information on chain so you can go back, read it later. It becomes very handy for lots of different things. So we're going to declare a new type of events. We're going to do event, and we're going to just do new post. So we'll emit an event whenever there is a new post made on our Facebook wall. And we're basically going to have several different things that'll be passed in here. The first thing is going to be an address. This is the address indexed from. And we're going to basically call this from. And so this spot right here is going to be for the person who's writing the message. So we know who wrote this message. Where did this message come from? That is what that parameter is going to answer. We're also going to do another unsigned integer of 256 bits for the timestamp. So we can know when did somebody post on our Facebook wall. And lastly, we're going to do string message. And this is going to be the actual message or the content of our Facebook wall message. Cool. And now we're going to start getting into the posts themselves. And so we want to define what is a post. And so very much like other typed languages, you can do structs or interfaces to declare the structure of, a piece of information. So we're going to do a new struct, and we're just going to call it post. Open this up. And in here, we're going to have, again, our address, which is our poster. We're going to have a string, which is our message. And lastly, we're going to have, again, the uint 256, and that is going to be our timestamp. So a post is basically made up of those three pieces of data. And we're going to declare one more set of empty state, and that is going to be an array of posts. So we just do post. This is the type. It's a struct of this post. And we're just going to call it posts. There we go. So that's an empty array that we can now use. And the next piece here is going to be called the constructor. And the constructor is sort of like the beginning of your smart contract. It's generally where you can pass in arguments that might be environment variables or something like that. So for instance, if you're initializing like an external contract that's already deployed on blockchain, you can actually, record what contract the address that is and interact with it. A whole bunch of other stuff. We're not going to use that for this contract. We will probably in the next one, as you'll see later. So we're just going to leave that blank for now. But just know you need that constructor to actually initialize or start up your smart contract. And now we're going to actually write some functions to interact with our smart contract. So the first one we're going to do is just do function create post. So we want people to be able to create a post on our Facebook wall. And it's going to take in just one parameter. We're just going to do the string memory message. And now we're going to declare who can actually run this function. We're going to say public. So that way anybody can access this function. And now we're going to do a couple things. First, we're going to increase the number of total posts, which kind of makes sense. If we have someone write a post, we need to increase that number by 1. So it continues to go up and up and up every time there's a new post. Next thing we're going to do is go ahead and push the post that just happened into our array of posts right here. So we're going to do post.push. And in here, we're going to use that, again, the struct. So it's going to be post, capital. And then inside this post, we'll go ahead and put all of our information. The first thing we need to put in is the address of the sender. We can access that with msg.sender or message.sender. And this is basically the person who interacted with the function. That's how we grab their address. Next thing we're going to add is the message itself. So we're going to pass that in from the parameter here. And then the last thing is timestamp. And it's actually pretty cool. You can just do block.timestamp. So when this is committed to the blockchain and it's actually run and goes on a block, that's how we get the timestamp, which is pretty cool. Now, the last thing we want to do is emit a new event, which is what we had right here. We want to actually record that log to the blockchain. And so we're going to do emit new post. And in here, we're going to add pretty much the same thing, msg.sender. And then the next thing is we have timestamp, so block.timestamp. And last thing is going to be that underscore message again. And let's see here. Gonna add that. All right, so we have our first function that is going to write post to the wall. Now we're going to do a couple of other functions that are kind of read-only functions, functions just to return data that is recorded on our smart contract. So the first we're going to do is just do function, and we're going to do get all posts. So this is basically going to return the array of posts that we're recording on chain. And so this is going to be a public view returns. So it's not going to actually do anything. It's just going to return data. It's not going to alter any state. This is why we're going to just label it as view returns. And we're going to put in what it's going to return, which is going to be, again, that post struct and is going to be memory. There we go. And the last step is going to go ahead and just open it up, and we just do return posts. Super easy. And then last read function we're going to do is to return the total number of posts. So we function get total posts is again public view returns. And this is going to return a number, which is that unsigned integer that we declared at the top. So uint 256. Open it up. And let's make this returns. Got to make sure you get your stuff right. Spelling. Do return total posts. And that's just going to return this piece right here that we're increasing every single time. Okay, so we have basically a smart contract ready to go. And the great thing with the Remix is we can go ahead and compile it right here in the browser. So just go ahead and run compile. That's going to compile it into bytecode, which can then run it in a virtual machine, whether that is actually on chain or in a virtual machine in the browser. So we actually have right here in deploy and run transactions, we actually have a kind of like local environment called, the Remix VM. So we can just use this right here. Comes preloaded with a whole bunch of stuff, like a bunch of blockchain wallets with loads of ether or currency that we can use. So what we're going to do is go ahead and we have our contract selected. We're going to hit deploy, and you'll see here there's a transaction recorded. It says the transaction was mined, executed, the contract was deployed. Here's all the bytecode for our contract. All there, very cool. And what you'll see here is under this deploy contracts, we'll actually see our Facebook wall contract right here has a contract address and everything. And so what we can go ahead and do is let's go ahead and record a message to our Facebook wall. We'll just say, hello world. Go ahead and do create post. And when we run create post, it's going to interact with our contract from this account that we have right here. And so if you actually see this here, you can see where the transaction came from, which is our address right here, all the information that we wrote to it. So now that we have a post on our wall, let's go ahead and return it. We can click get all posts. You can see the decoded data right here. It might be a little bit small on your screen, but it's going to go ahead and declare the types here. So it's going to say you're going to get an address, a string, and a unsigned integer 256. And so here we have the address of the person that wrote the message, which is us in this case. It's this right here, ending DDC4. See DDC4 here. There is our message, and there is our timestamp of the block.timestamp that we used earlier. We could write another one. You could say hello world again. Create another post, clear this, and then just go ahead and do get all posts again. And you can see here that this has gotten longer. So we had the initial thing, and it's just another array of more posts and more information. And that's basically the simple version of a smart contract with nothing fancy. So if we go back to our presentation here, just a quick review of what we've learned so far. So we've learned that you can have state that holds data on chain, and you can manipulate that state just like we did with the total of post or the array of post. You can use events to emit logs of data that you can look at the contract after the fact, and it's kind of recorded in the immutable ledger, which is really cool. Constructors can be used to take initial arguments in, which we'll look at later. And also you can have functions that make operations. They can update state. They can do a whole bunch of things. They can, require money, all sorts of really cool stuff. So that's the simple contract. Let's go ahead and do one more contract. And I saw that you guys were going to be building an NFT gallery. So we're going to go ahead and mint an NFT, and we'll show you the basics of what minting an NFT looks like. So generally with NFTs, we saw earlier that we stored some of that state on chain, such as the post. Generally, storing data like that directly on chain eventually gets very expensive because you think about a Facebook wall, if it gets really long, you're going to have loads and loads and loads of posts, and eventually it's going to get very expensive to pay the gas fees for the blockchain to actually keep writing that data. And that's actually where Pinata comes in. Pinata is an IPFS provider, and IPFS, it stands for Interplanetary File System. You can kind of think of it like decentralized file storage. So what you can do is put something on IPFS on this decentralized network that, shares files, and then you can put the reference to that file on chain. So instead of having a whole bunch of data that is crammed into the blockchain and costs a lot of money, you can have just a single pointer reference, like a link in some ways. But it's a very special link because it's, cryptographically hashed, it's immutable, and so you prevent cases where someone might post something, then you lose, if they are able to manipulate that link, like a server, take the link down or something like that, you lose the value of the blockchain and its immutable history and things like that. So IPFS and blockchain go hand in hand, and Pinata just makes it really easy to use IPFS. And so we'll show you that right now. So if we're going to mint an NFT, we're basically going to need two things. So we generally need an image, like the main piece of content, and then we're generally going to need some information about the NFT. So this can be things like what's the name of the NFT? Does it have any special attributes or description, all this stuff. So I got my terminal open here, and you can access Pinata multiple different ways. We have SDKs, you can use our web app. I'm personally a big terminal fan, so that's where I will be living here. I'll just go ahead and CD into my desktop. And you can see here I have a penny.png file. Very nice. This is our mascot Penny. And so I want to go ahead and upload Penny to IPFS. So I'm just going to do Pinata upload, and I'll just do penny.png. And there we go. So we just uploaded Penny to IPFS. And we got this piece right here. This is called a CID. This is a content identifier, and it's a cryptographic hash based on the contents of the file. So no matter how many times I upload Penny to IPFS, I'm going to get the exact same CID every single time unless I change the image. Once I change just one pixel of that image, I'm going to get a different CID. So basically, this CID is based on the contents of the file and basically makes it, a great way to verify that the content hasn't changed. And it also acts as an address to the content. We can, basically request this CID through, an IPFS node, or we can request it through an HTTPS gateway, and we can actually retrieve that data back, which I'll show you in just a second. But the important piece is here is that we've uploaded our image, and now we're going to need some metadata like the name, descriptions, things like that. And that is going to be basically the what they call the URI, Unified Resource Identifier, and it's basically all the information about the NFT that we're making. So we're going to do a new file just called metadata.json, just created it here. Just going to open it up here, and we're just going to go ahead and put in some information. All right, so we have some basic, JSON here. So the name, I'm just going to call Penny. That's the name of our NFT. Description, let's say a nice pinata. We have an external URL, which is our website. If you were doing an NFT project, this would be, the website to your project, something like that. And then we have image here, and this is supposed to be a link to the image somewhere else. And so instead of a, more traditional server, we're going to actually use the IPFS protocol, and we'll just go ahead and put that CID from Penny in here. There we go. So we have our IPFS reference to our image. We have all of our file information. We're going to go ahead and save that file. And so we have metadata file. Now we're going to upload the metadata file, and that's going to give us our, URI. So we do pinata upload metadata.json. There we go. So we have our metadata. And so the way this works is we'll put this CID on our smart contract. And so anybody that wants to know about our NFT, they'll see the CID, and then they'll fetch it from like something like an IPFS gateway, which we could do real quick. So we could do just a quick simple curl. And this is a gateway right here. It's a My Pinata gateway that you can get with your account. And you can see here we're pasting in that same CID. So if I just request this and parse the information, there's the JSON data that we just uploaded. So pretty cool. So I'm just going to save this right here. Now the next step that we need to do is actually write a smart contract for the NFT. And one of the concepts that we're going to go over real quick is kind of smart contract standards and libraries. So as smart contracts started getting more traction, they started to realize we kind of need like an official standard to make sure that we're all on the same page as far as what an NFT is, right? And so they started developing these things called ERCs. This kind of basically like a standard that you can use across the Ethereum ecosystem, and everybody's going to be agreeing, okay, this is the core things that an NFT must have. So the most common is ERC 721. And this website here is wizard.openzeppelin.com. They kind of maintain a lot of these standards for smart contracts. And you can see here, this is kind of like an open play editor. And we have a couple of things here. You see here is we have an import of ERC 721. So we're importing a contract base from a library. So we can import a contract, say our contract is ERC 721, and then build on top of it and add additional functionality. So we're making penny NFTs. So we're just going to call the contract pennies. The symbol is going to be pins. We're going to leave the base URI blank. We don't need to worry about that. I do want it to be mintable and auto increment the token ID. And we'll go ahead and put URI storage here. There we go. So this is basically the simplest NFT really you can have. It's nothing fancy. And what's great with the Open Zeppelin's wizard here is we could actually open and remix that tool we were using just a moment ago. And so you can see here our contract just opened. We're importing some libraries from Open Zeppelin, and our pennies contract is, ERC 721, URI storage, and ownable. Now, if we go down through this contract, things are going to start looking really familiar. We have, again, this unsigned integer, state. This is the token ID. So after each NFT is minted, it goes from token 0, token 1, NFT 2, NFT 3, etc. So that's increasing as it goes. We have our constructor, and we can actually see it's being used here. In this constructor, we have the address of the owner of the contract. One of the special plugins or features we're using with this contract is called Ownable, and it basically allows you to, restrict who can do certain things on the contract. So, for instance, we may want everyone to mint an NFT, but let's say we were charging money for those. We only want the owner to be able to maybe withdraw the funds from the contract, kind of like a bank. So Ownable is used for that. And when you deploy the contract, you can pass in the initial owner, the address right there. So we'll just leave that as is. And then right here is our main function. This is our function to mint NFTs. And it takes a couple of parameters. It takes, who it's sent to, the address. So you could say who you're going to mint the NFT to. It also takes this right here, the URI. And that is that metadata URI that we were just going over just a moment ago. It is the Unified Resource Identifier. It is all the information about that NFT, and it's on IPFS. So that's what that is there. Now, generally, we're not going to actually put this information in every single time because we don't really need to. So we're going to streamline this contract just a little bit. I'm just going to take this piece out here, just leave this blank. And as far as who is going to get the NFT, let's just go ahead and say whoever interacts with the contract. So we'll just do message.sender. So whoever mints, interacts with this contract and mints the NFT, they're the ones who are going to receive the NFT. Now, as far as the token URI, this is where we're going to go ahead and pass in that IPFS state that we had earlier. So we're going to go ahead and do string, do IPFS : and just put in that CID that we had earlier. There we go. So every time you mint an NFT, it's going to be the same NFT. There's methods you can use to make the NFTs different every single time. So when you do your project or your workshop about building an NFT gallery or something like that, you'll probably be doing a different method so you can have different NFTs every single time. So it's totally doable. And these are just some helper functions that are required for the contracts. We're just going to leave those as is. And we're almost ready. The last thing I want to do is right here, we're restricting this mint function to only be used by the owner. I want everyone to be able to mint my penny NFT, so I'm just going to just take that out. And we are all set to go. So I'm going to go ahead and compile the contract, just like we did before. And so we can see here, we're going to have a new deployment here. We have the pennies contract that we had earlier. And you can see here our deploy function requires an input. That's what this constructor is. And so it's asking who is the owner of the contract, who's going to be the owner. So I'm going to go ahead and copy the account address here, paste it in, hit deploy. And so you can see here our contract went through, it was deployed. We have our deployed instance right here. So we have all these functions, a lot more here than we saw before. And something else you'll notice is, we only see like maybe 3 functions on this main contract here, but we see a lot more over here. And that's because we're kind of importing, those functions are behind the scenes and they're inside of these imported libraries. So those functions are available to us. We just don't see them on this because, they're in the background and they're imported. They're kind of like plugins. So we have our functions, we have our contract here. Let's go ahead and mint a couple NFTs. So I can just hit save mint. And I just minted 2 NFTs. And now I can actually look at the contract and run some of these functions to, see, how many NFTs are there, what is out there. So I can actually copy my address and say, what is my balance of NFTs? We might have an issue. It says there are no NFTs. I might have done something wrong here. No, it seems right. Maybe I didn't post this in right. Oh, I think I was copying the wrong address. Let's try this. There we go. Yeah, put in the wrong address there. So we actually have a balance of 3 NFTs now. I've minted 3 of them. And that means that our token ID went from 0 to 1 to 2. So I can basically ask who's the owner of token ID 2. And there's our address that was minting those NFTs earlier. And if I wanted to say, okay, so we have these NFTs, we have these tokens, but what is the information? What is the image? What is the name? What is the metadata? That information is retrieved through asking what is the token URI. So I can put in, token ID 0, and it's going to return back that IPFS hash we saw earlier. And so what you'll probably see when you're building your NFT marketplace, what those marketplaces are going to do is they're going to go through those contracts. They're going to use programming to hit all these functions to get all this information so they can figure out who owns NFT 0, what is the name of NFT 0, what is the image of NFT 0, all this different stuff, and then put it on a website where you can actually view it. And that's NFTs, just right there. We just learned all about NFTs for most of it. So, one more quick review of, what we just covered with minting and NFT contracts and stuff like that. Of course, the big one is you can import other libraries of other smart contracts into your own and build on top of them. Another thing we learned is, if data is too big to store on chain, such as images and things like that, you can store it off chain with IPFS using Pinata, of course. And I think another thing we learned is that NFTs are just unique tokens with a pointer to off chain with all the data. So you're basically saying this is a token, and everything we want to know about the token is off chain. And that information that we're querying, that is the metadata, which has all the info about the NFT, including a link to the image as well. So if we wanted to take this a little bit further, and if you're curious about, okay, so I know sort of the basics of smart contracts, what do I do next? I would highly recommend some of these steps here. First one would be to, maybe get a crypto wallet and find some testnet funds. Testnet funds are not real money, so you don't have to worry about accidentally losing your money. So you can get a free wallet, you can get some free testnet funds from some faucets, some places that basically give you free testnet funds. And that way you can actually start trying to deploy your contracts to actual testnet chains and interact with it on test blockchains, essentially. I would also highly recommend maybe trying out local development. All of the smart contract development we did today was inside of Remix. It's usually good practice to try that stuff out locally on your computer. There's some programs you can install and run that allow you to run and compile smart contracts and deploy them, from your code editor. So that's a very big one. I would highly recommend that. And then the last thing I would highly recommend is building a web, front end or client to interact with your smart contracts. The really cool thing with these smart contracts, in a lot of ways, they can act like a dedicated back end to a full stack application. That smart contract can hold all of the business logic. It holds who owns what, et cetera. And so your front end can basically be just a client to access that contract. You can use libraries to make transactions with contracts and get information from these contracts, which is really cool. And so as far as resources, I would highly recommend you check out our docs.pinata.cloud/blockathon. That is going to be all the information for the Midwest Block-a-Thon. We can check it out real quick. .cloud/blockathon. There we go. So it's a dedicated page just for the Midwest Block-a-Thon. It's going to have all the information you need to know about how to get started, what is Pinata, quick start for Pinata, loads of tutorials. That Facebook wall that we did earlier, I actually have a full end-to-end application with repos that you can check out. I called it the DAP book. Uh, so you can see here some other hackathons where we've made some posts here, and you can actually connect your wallet. It's actually going to write to the blockchain. You can upload images. Super cool. All of the, contracts are all open source, so you can go here, read all the information about how the code works. It has loads of comments. So this is a really rich example if you want to learn an end-to-end how to build a smart contract application. We also have loads of tutorials, so if you want to learn how to use some of those local development tools, Foundry and VM, this is a great one because it goes again end to end. We have, things how to use different alternative blockchains like Base, which is kind of like a faster, cheaper version of Ethereum. We have things like how to use Pinata with cursors and other LLMs. So if you're using AI for your development, we have some really cool tricks that you can use to have the latest information of Pinata. We also include something called private IPFS. So all the stuff we did with IPFS earlier is on a public network. It's all publicly accessible. So if you wanted to store something that was sensitive or you want a token gate, private IPFS is really cool for that. And we have like this concept of how to make private NFTs. So if that sounds interesting, I recommend it out. If you want to go really hardcore, I highly recommend this one on how to build an NFT indexer. It's actually very handy if you're going to be building something like a marketplace. And it's basically special software to actually index all those events that are emitting logs. You can basically index all the logs and basically build your own database and API with it. It's super cool. So again, this is going to be docs.pinatacloud/blockathon. Highly recommend you check that out. We have a Discord, so discord.gg/pinata. So if you're really eager and you want to start building with Pinata and you have some questions before the hackathon next weekend, feel free to jump in there. I'm pretty active in there, and I'll be sure to looking out for your message if you have questions. And of course, my email is there too, steve@pinata.cloud. Happy to, answer any questions or things you might have. Getting started with Pinata is super easy. We have free accounts, and the free account pretty much covers anything you might need. But if you end up needing some paid accounts for the Blockathon, for the hackathon next weekend, just let me know. We can certainly work that out as well. And yeah, so that is pretty much my presentation for this evening. So if you guys have any questions, I'd be happy to answer those.
Yeah, hi. Can you hear me?
Yes, sure can. Yep.
Awesome. Hey, I want to say thank you. It's really actually kind of satisfying to watch you write the whole contract from scratch. So thank you for that. One question I had was about testnet providers that you recommend. You mentioned it a couple times. I used to use Polygons, but that kind of sunset. I'm looking for a new one. Just wondering if you had any recommendations for me.
Yeah, totally. So there are two probably that I would highly recommend. One is going to be Sepolia, which is the Ethereum mainnet testnet with Sepolia. Another one is Base Sepolia. So Base is a layer two blockchain. It's kind of built on top of Ethereum, and they have a loads of support for building stuff with them. So, quick start of how you can basically spin up an app and all this other stuff. But they have a um, testnet called Base Sepolia that is pretty easy to get testnet funds for. You can see like they have free to use RPC URLs that you can deploy stuff to. Something I didn't mention in our session here, what's really nice about what's called EVM based chains. EVM again standing for Ethereum Virtual Machine. Uh, EVM chains basically all work the same way. They all use Solidity. They can all compile and basically deploy on any testnet. So what's nice about that is like that contract deployed for the Facebook wall. I could deploy that on Sepolia. I could deploy that to Base Sepolia. All I have to do is make sure I get some testnet funds for an account, and I have an RPC URL to deploy it. Um, so yeah, generally, if you need to just look for like faucet or funds, you could generally look like Base, Sepolia, faucet. This is where you can get some testnet funds. And so they'll actually have a whole bunch of different wins you can go and visit and, get some testnet funds. If you now, generally the testnet fund faucets can be abused. And so sometimes it could be a little tricky getting a hold of some. So if you're one of those people and you're stuck and you're like, I really need some like testnet ETH on Sepolia or Basepolia, hit me up. I got plenty. I can certainly help you out.
Hey, well, thank you for that.
Yeah, no problem. Good question. Any others?
Thank you so much, Steve. I think that was a really great, concise, like really fleshed out understanding of what smart contracts are. And
Thanks.
one question that came out to me is, so since we're considering the time constraint on this, and I know a lot of people really aren't going to be starting learning about this, we have a lot of beginners coming to this hackathon, and they're not going to probably think about it until the day of. So I was wondering if you had any advice for people using like LLMs, ChatGPT, Perplexity, whatever we're doing. Like,
Mm.
what kind of vocabulary would help them to go through these LLMs and ask like, what methods do I need in my smart contract? How can we best use LLMs in our development?
Yeah, it's a great question. What's nice is that most LLMs are going to be pretty up to date with a lot of smart contract development. A lot of the stuff that we did today is like years old. It's actually really standard run-of-the-mill stuff. So if you're like, how do I mint an NFT in Solidity? It'll probably give you all the instructions, including different ways you can deploy it. Um, I think where the rubber meets the road with LLMs and what you might encounter is like sometimes the Solidity stuff hasn't really changed at all, and you could just say, write me a contract Solidity, or how do I do this in Solidity? It's usually going to give you all the right information. The stuff that does change is things like the test nets. So, for instance, what happens is people will spin up a testnet blockchain for like Ethereum. But eventually the testnet gets so old and overloaded and so slow and so expensive that they have to spin up a new one. And so, like, I think when I started, it was Rinkeby, and now they've moved on to, and then they moved to Gorley, and now it's Sepolia, and they're actually getting ready to move to another one. So the test nets is probably the hardest thing that's going to be changing the most, and what your LLM may not be up to date most. So with those, I would highly recommend checking out our docs because, or our blog posts on how to, deploy contracts, because those are going to use some of the more up to date test nets. That's probably the main thing you'll want to keep an eye out for. The other thing that might help as well, try to use some of the more modern libraries. So there's going to be two main ones you'll probably want to be aware of. And actually, we have a blog post on them. So let me go to it real quick because it's all in one thing. And this is on the actually the Block-a-Thon right here. This one right here. These two libraries, Foundry and VM, are probably the more two up-to-date libraries, and you'll make sure that they still work because another thing that happens in a lot of blockchain development is some of the JavaScript or TypeScript libraries you use to interact with smart contracts, those get outdated. So Ethers is probably one you may want to avoid. Hard Hat is another. So Foundry and VM and how to use these right here is will be hugely important and very helpful to you. And a lot of those LLMs, if you ask them about how to use VM or how to use Foundry, they'll have the information. So it's just knowing to request for that specifically. And yeah, and very briefly, the Foundry is what you use to write and compile the smart contracts and deploy them. And then VM is like a TypeScript library you can use in a web application to interact with them, or in a backend as well. So that would be my tips personally. That's what I would do.
Thank you.
Yeah, no problem. Good question. And I will say too, we also have, if you are want to take advantage of all the AI stuff with Pinata, we actually have LLM docs. So you can actually use this inside of Cursor and it'll pull all the information. And this is basically a super condensed AI version of our APIs and SDK. So it'll have all the information. And I think we have both a blog post and a video on how to use these inside of Cursor, inside of Zed, which is like my personal favorite, or how to use them inside of something like ChatGPT or Claude. You can use in all of these. So if you need anything Pinata related, they'll most likely be in here too. And I have one more. I need to put this on the Blockathon page. We have Ask Penny, chat.pinata.cloud. This is something our head of product built, and it's pretty special because we basically used something called vectorization with files, which is a little more AI focused. But we used it with IPFS, and we actually took all of our blogs and all of our docs, uploaded them to IPFS, vectorized them. And so this is basically a vectorized search of all of our past blogs and all of our past documentation. So you can have like, there's probably a really great wealth of resource and knowledge here. So I could say, how do I mint an NFT on base? I know we have a blog post on that. So that's going to basically query vector, all of our stuff and go through like maybe some of the simple steps, stuff like that. So it has some pretty cool stuff. But once again, you got to be careful with LMs because it's going to say base Gorley. That's an old one. So again, my point still stands. You got to be careful with LMs. Yeah. Another great question. Anything else?
Well, if there are no more questions, this isn't the last time you'll be hearing from Pinata. They will be at the Midwest Block-a-Thon, and you'll be able to ask more questions, maybe specifically about their track and about, their platform and stuff. And you guys are giving a in-person workshop, correct?
Yes, we sure are. So this workshop was more focused on smart contracts. So we only briefly went over the IPFS stuff. The workshop we'll do in person, or that I'll be giving in person next weekend, will be very heavy into IPFS, how to use Pinata, and how you can, qualify for our tract and everything.